Hey, Sam here with Breaking Squelch, and today we're going to be talking about NVIS antennas and how they can help you in an emergency. So I actually tried to record this video a while back, a few weeks ago, um, but when I started trying to record uh, there were a bunch of solar flares, and it kind of messed up a lot of radio here in North America. Uh, so it all just kind of went downhill from there. I was also going to make this into like a three-part series, but I think it's just going to be better if I just make it into one video. Um, I also tried to record writing on paper while trying to film that. That didn't work very well. I don't have a tripod big enough, and I tried hanging over a cardboard box, and that didn't really work out too well. So I just went ahead and wrote everything down, and I'll just use my phone as a camera from there. Um, but what are we talking about today? NVIS. So, um, and mainly how it applies to emergency situations. I'm sure one day I'll go over, how you can use it in tactical situations or just, as fun. Um, but today we're really worried about the emergency aspect of it. Like if you get stranded in the woods or if you wreck your car off the road and nobody's around, something like that. Somewhere where it's imperative that you talk to somebody kind of local, more than somebody outside the state, because they may not know the state or where you're at better than somebody who's in that 300-mile range area. So let me kind of show you what NVIS is on paper, and then after that, I'm going to actually make a NVIS setup. I'm going to go walk out into the middle of the woods, and we're going to set it up and see if I can make any contacts. Kind of a difference that I'll be doing than what somebody who's actually in emergency is going to be doing. In an emergency, you're not going to say CQ, CQ. You're going to say Mayday, Mayday, and people are going to pick you up a lot better for that. Heck, even I skip over people I hear saying CQ sometimes. It's just not what you want to do at the time. Also, I will be trying to call to get somebody to answer me. I'm just going to be trying to prove a point in a way that you can use QRP radios that are single sideband to do this, like a poor man's setup, and it still works. But if you're really in a situation, you'd be wanting to try and hit people who are already in a QSO in a conversation. You're going to be trying to talk to people in nets. You're going to be trying to, if you can find somebody who's already there, start saying Mayday just as soon as they let off the mic, and somebody will pick you up probably. And that's probably going to be your safest bet on getting somebody. Or if you can find a POTUS station or something, start saying Mayday, Mayday. Somebody that you can actually, that's going to hear you and get a hold of you. But what I'm going to be doing is just calling out CQ and see if I can get anybody to pick me up. But first, we got to go over that paper. So I'll bring you down there and let's look at it. All right, so please excuse the the bad filming here. I'm having to use my phone. I'm on my bed and I'm trying to. The lighting's not very great, but hopefully you can still see the paper, and it kind of gives you an idea of what we're talking about here. So we're talking about NVIS, or Near Vertical Incident Skywave. Near vertical, meaning that obviously we're going straight up in the air, almost, and then incident skywave, meaning that we're actually bouncing it off of the atmosphere, or the ionosphere in this case, which is very high up above the Earth, and I can't give you a measurement right now. So, most of the time when we're doing, at least what I'm doing, when I'm doing POTA or really just talking at all, I actually do vertical antenna. You've seen me out there put up my station before. It's just easier to do that right there. And this is a vertical antenna, and this is kind of what the propagation looks like off of it. So you don't really have any stuff coming off the top of it, but you have a lot of stuff coming out completely horizontal to it. And what this means for us is if we put that in like a broader aspect, when it comes off, this is no joke about the curvature of the Earth here. When it comes off, it goes up and hits the ionosphere and bounces back down on this side of the Earth. But when we're trying to do NVIS, we're trying to kind of talk in this area, actually, really. So when it's bouncing like this, sure, you can make a lot of DX contacts. You can make people on the other side of the country here in the U.S., but it doesn't really work good for local contacts or people who are just within the general vicinity. So, and just like I said, most power goes horizontal, and you can't really make any contacts, under 300 miles with this. And not saying it won't happen, but it's just very, very rare. Um, this is what we're kind of looking for. So this is a dipole. I think everybody knows what a dipole is at this point. If you're watching my videos, you probably know what a dipole is. And what it is just basically a vertical antenna you've turned sideways. So all your power is going up and down like this. There's nothing coming out the ends. So we're getting our power to come up here and bounce back down like this, straight up. This is what it looks like from the side view. It's a 360 degree. I'm trying to think of the word for it. Basically, the power is coming out in 360 degrees, but none of it's coming out this way towards us. It's all going up and down, and a little bit of it is going sideways, and that's how you can make long distance contacts with the dipole, but for the most part, most of it goes up and down. And this kind of applies to inverted V antennas too. So let me turn the page here. Alright then, so we'll get into inverted V's here in just a minute. So maximum usable frequency, that's what we're kind of worried about here. So the maximum usable frequency is, I drew a diagram here, is basically the maximum, is the number, maximum frequency that can actually come up, hit the ionosphere, and bounce back down without shooting straight through it. Right here, if you look in daytime, that's normally about 7 megahertz, and at night it's about 3 megahertz, or 40 meters and 80 meters respectively. And again, it can go higher than 40 meters, but reliably it's at 40 meters. I've had in the dead of summer it go up into 20 meters and making NVIS contacts. It's just not reliable that way, and you can definitely hear the fade out if you're talking to somebody close. I remember I got a station in South Carolina, because I'm in Georgia right here, and we were having a pretty good conversation. All of a sudden, he just dropped out, and that was an NVIS contact on 20 meters. But all of a sudden, the band shifted, and that maximum usable frequency fell, and he just drifted away, and I couldn't talk to him anymore. But with 40 meters and 80 meters, you really don't have to worry about that. And again, this is kind of what it's looking like. So 40 meters is going to come straight up and bounce back down, but if you were going to use 20 meters in the same fashion, it would just fly straight through the atmosphere. And so let's go back, and this is just kind of all I wanted to show. This is an inverted V, by the way. This is what an inverted V looks like. And what an inverted V does is it kind of angles your where your power is coming out, and it angles it almost straight up. I actually use antenna modeling software, and I'll put in a picture of that right here in the video, and it'll show you what it kind of looks like which way the power is coming out. Most of it goes straight up is what I'm trying to say. Alright, so we kind of looked at it on paper, saw what we're really looking for here. Please mind me, I'm actually using a script right now, so if I mess up, bear with me. So in survival, your best bet's going to be a 40-meter wire antenna in an inverted V fashion. And we saw why a minute ago, why an inverted V is the best for a few reasons. One, most of your power, you don't really have to worry about it coming off the sides, because most of it goes straight up. And even when the sides tilt down, it pushes that up. So you do get just a little bit of long range with it, but mainly it goes straight up. Especially what you do with an inverted V is you don't put it, and take that back, when you use a dipole or an inverted V, mainly a dipole, what you do is you actually put it about a half wavelength up in the air, and that kind of negates the NVIS portion of it a little bit. It makes it more go out towards the sides, and not that it doesn't go up, but a lot of it does go out towards the sides, and so you kind of get a broad range of coverage. But when we're just hiking around, or you're in a survival situation, you probably can't get your antenna that far up in the air. It's just not going to work. So for NVIS, luckily for us, the lower you can, well, give or take some, the lower you can get it to the ground, actually, the better it's going to go straight up, which is what we want. So in survival, the best bet is a 40-meter wire antenna. in an inverted V fashion. It's lightweight. It's going to be easy to deploy. You don't have to worry about, like with the dipole, you have to tie it to trees. You're going to have to find a tree to tie it to that's equal distance from the one you already have it tied to get it set there. And again, I want to say I don't want to worry about 80 meters right now, because our main focus right now is 40 meters. 40 meters NVIS, because with 80 meters, that's more of a nighttime thing. Especially if you're in summer, something lightning's just going to kill you on 80 meters. The noise floor is going to be kind of high. So 40 meters is what we're worried about. And also at night, if you're in a survival situation, you'll be sleeping, getting some rest. So you don't need to be worrying about that. When in my hiking bag, what you'll see me use is I have a nice thick piece of coax with a toroid on it. And I've got a notepad I carry around with me everywhere. It's kind of bulky, but you don't need all that for just if you're just specifically making a little bit of a survival kit. Really a 6 foot to 10 foot mini coax SMA cable would work just fine. At that range or at that distance of coax, you're not going to have any loss really, at least noticeable loss from your at that frequency or anything. You're not going to lose any power with that kind of small coax. And it's really lightweight. You can wad it up this big around. It's 10 feet of it. And what else you're going to need? A QRP station with single sideband. If you can do more, that's better, but single sideband is going to work just fine. And that's what I'm going to be trying to show you, is that single sideband is probably, when you're trying to communicate with somebody, that's going to be your best bet, is single sideband anyways. If you could do Morse, you could get a lot more power out there, but a lot of us can't do Morse. And on top of that, a lot of people don't understand Morse if they heard it. So, and today I'm going to be kind of showing you a poor man's setup, if you will. Everything I have in my bag cost me under $200, and 90% of that was the radio. Everything else I built by hand, except for the coax, obviously. I bought the coax, but it was just a CB coax I bought off of Amazon. Just some 50 ohm coax. The toroid was off of eBay for like, I think I got it for like $5 or something, and I wrapped it myself. You don't have to have a super bunch of expensive equipment. Just if all you're doing is QRP work and you're worried about survival or something like that, you don't need a bunch of expensive equipment, although it would be nice to have. So yeah, I think that's it. I think what we're going to do now is I'm going to go get my stuff, walk out into the middle of the woods, and I'm going to set up. I'm going to show you that you can make contacts and you can get help just with very, very basic minimal stuff in your immediate area. Because again, like I said before, people in your immediate area, because like, why do you want NVIS? The reason being because people in your immediate area are going to know you, like your area, your situation better than somebody, you know, in Alaska is going to know your situation. So let's go out there and let's do that, and let's see what happens. Alright, so it's the next day, and I've come out here and I've set up out here in the woods. Now I'm not going to lie and say I'm in the middle of nowhere. My college is literally right there. I think you can see it. But it's a nice little piece of woods I can get down to, and it's enough vegetation. I think it'll replicate kind of scenarios we're thinking about here. So let me show you what I got. Alright, so I have my radio set up on this log. I've got my antenna, an inverted V. It comes out down there. And the same thing's on that side. I'd say it's probably about 8 feet, 7 feet or 8 feet in the air. And let me sit down here and set up, and we'll see if we can't make any contacts. Alright, so sorry for the weird viewing angle. This is about the best I can get here on this log. But, so what I'm going to be trying to do is call CQ and see if we can't get a hold of anybody. And if that doesn't work, I think I'm going to switch over just scrolling. I'll try and find some POTUS stations or something. Not going to go on my phone though, because we're trying to replicate an emergency here. And we'll just see if we can get a hold of anybody. So, here we go.
Goes well for hunting, 73. QRZ, this is Wild for POTA, W4P, special event station for part Kilo 2171, parts on the air.
Kilo Oscar 4, Kilo Sierra Juliet, QRP.
Was there a Kilo Oscar station come again?
Kilo Oscar 4 Kilo Sierra Juliet.
Kilo Oscar 4, Kilo Sierra Juliet. Is that QSL?
QSL. I'm running 8 watts into an NVIS antenna, and I'm in Golf Alpha.
Copy the thing, 3x4. Can you come again with our signal report?
QSL 595959.
Roger, roger. Got you there faintly. Thank you so much for the contact on 73 for part Kilo 2171.
73. Alright, so as you saw, we just got a hold of somebody. Couldn't really get a hold of anybody just by calling CQ. It can be done, but today I just don't think it's a really great day, and I don't have too much time to just sit out here and keep on calling CQ. Eventually somebody would answer us, though. I know that. My radio's also got the SWR, and I was checking it. I'm almost at 2 on the SWR, and most of the time it runs about 1.2. So it's kind of weird to have that happen. The only thing I can think of to diagnose it would be to probably raise up these ends. It's kind of in some real kind of thick vegetation on the ground since I'm in South Georgia. It's probably what's kind of run it around. I could move them around though, and it'd probably lower my SWR. But as you saw, we got a person in Don Carter State Park, and that's in Georgia. So that was an NVIS contact right there. As you saw, he was coming in really good. We didn't get to him very well, but I think that was probably because of SWR. And we would just need to work on that. And if you were in a situation, you'd have the entire day to do this. Well, not the entire day, but you'd have a good bit of time to just kind of play around with everything, make sure it works. And in all reality, I think that's what you'd want to be doing anyways, would be trying to catch people who are currently talking, because you know that if you can hear them, then they can probably hear you. Again, you'd be wanting to call Mayday, a bunch of other stuff, but we got a hold of a guy in Georgia. I'm in Georgia, and I'll put the distance and everything just right here down below. But yeah, I think it was a success. If we were in a real emergency situation, we would have just got out of it. So, or at least gotten really close to it. So yeah, I hope you like this. And the only thing that I would want to add would be that for a coax in a line like this, I'd say you could just use a short 6-foot piece of mini coax would work just fine here. Anyways, guys, thanks for watching, and I'll see you next time.